Complex specified instructions in the context of computer science and software, and how these point to intelligent design in the biosphere. In computer science, the concept of complex specified instructions is particularly relevant when analyzing the architecture of software systems, algorithms, and programming languages. Much like biological systems exhibit complex specified information, CSI, in structures like DNA, software programs embody highly organized sets of instructions that are both complex and specific in their functionality. The parallels between biological systems and software highlight the deep design and logic embedded in both, pointing to an intelligent source behind their development. Understanding complex specified instructions in software. Complexity in software. Complexity in software refers to the intricate, detailed, and often interdependent relationships among different components of a software system. This could involve large amounts of code, a variety of algorithms, multiple modules, and a wide range of data structures. In a well-designed software system, complexity is not random or chaotic but reflects the layers of abstraction and functionality that must be executed to meet specific objectives. For example, operating systems like Windows or Linux are complex systems composed of millions of lines of code that interact with hardware, manage resources, and allow the execution of other software. The complexity of these systems comes from the necessity to control a vast array of tasks and hardware components concurrently. Specification in software. Specification refers to the precise, ordered, and goal-directed nature of instructions in software. Each piece of code is designed to perform a specific task or set of tasks. The specification is outlined by developers, following the rules of programming languages, to achieve desired outcomes. It ensures that the complexity in a program is not arbitrary but directed toward solving a particular problem or fulfilling a purpose. For example, in a sorting algorithm, the instructions are specified to take an unordered list and return a sorted version of that list. The steps to achieve this are highly organized and precise, following strict rules of logic to ensure that the algorithm works correctly every time. This specificity ensures that the desired function is achieved without deviation. The role of an intelligent agent in software development. Like biological systems, software development requires an intelligent agent, a programmer or team of programmers. The role of the developer mirrors that of a designer, arranging complex sets of instructions, the code, in a way that fulfills specific functions. While a program can automate tasks, the process of creating software involves deliberate, thoughtful planning. Programmers must write code that not only performs the task at hand but does so efficiently, securely, and in a manner that is maintainable. This involves foresight and expertise, akin to the teleological purpose found in the design of complex biological systems. Without an intelligent mind orchestrating the development, the complex specified instructions that underlie functional software would not emerge. Examples of complex specified instructions in software. Operating systems. Operating systems, OS, like Windows, Mac OS, or Linux serve as excellent examples of complex specified instructions. The OS coordinates hardware and software resources, enabling the computer to perform tasks ranging from simple file management to running complex applications. The OS operates based on intricate, layered instructions, memory management, process scheduling, file handling, and device input-output control. Each of these tasks must be managed in a specific, coordinated way. For example, a program that requests memory needs to interact with the memory management module in a highly structured manner, ensuring that memory is allocated efficiently and safely. This specificity allows the OS to function properly across a wide variety of hardware configurations and use cases. Compilers. A compiler translates high-level programming languages, like C++ or Python, into machine code that a computer's hardware can understand and execute. The process of compiling a program is itself an example of complex specified instructions. The compiler must understand the syntax and semantics of the source language, perform error checking, optimize code, and then output an executable form of the program. Each step in the compilation process is carefully specified to ensure that the resulting machine code works as intended. The complexity comes from handling a wide variety of source code patterns, while the specification ensures that valid code is translated into correct machine instructions that perform the desired functions. Artificial intelligence, AI, algorithms. AI systems, particularly machine learning algorithms, often operate with complex layers of specified instructions. For instance, Neural networks are modeled after biological neurons but require an explicit set of instructions to perform tasks such as image recognition or natural language processing. Each layer of the neural network contains specific parameters and weights that must be tuned to achieve optimal performance. The complexity arises from the many layers and parameters that interact, while the specificity comes from the fact that the algorithm is directed toward solving a particular problem, such as recognizing objects in images or predicting future trends based on data. The AI does not learn randomly but follows a well-ordered process of training, feedback, and optimization that is intelligently directed by developers. Why natural processes alone cannot produce complex specified instructions in software. The development of software and algorithms provides a clear example of why complex specified instructions cannot arise from unguided, random processes. Here's why. Absence of random code generation. Randomly generating code and expecting it to produce functional, error-free software is analogous to expecting random mutations to generate complex biological systems. Even small programs involve intricate interactions between variables, functions, and system resources, and a single error can crash the program. Likewise, software that lacks clear purpose or direction, i.e., specification, would not fulfill any meaningful function. Developers play a critical role in writing code that meets particular requirements and ensuring that every component works cohesively toward a purpose. Without this intelligent guidance, the instructions would not result in functional software, just as random processes in nature fail to explain the origin of irreducibly complex biological systems. Optimization and efficiency. Functional software is not just a collection of instructions, it is often optimized for speed, memory usage, and security. These optimizations require intentional design. For example, software engineers may choose to implement specific algorithms because they perform better under certain conditions, or they might restructure code to make it more maintainable. Similarly, in biological systems, functional complexity combined with high specificity suggests optimization, which further points to the involvement of an intelligent designer. Random processes may occasionally produce something functional, but optimization toward a specific goal is a signature of intelligent planning. Debugging and error handling. In software, when errors arise, programmers use debugging processes to find and fix the problems. This illustrates another key difference between natural processes and intelligent design. Without intelligent intervention, errors in a system lead to dysfunction, not improvement. A randomly generated program with a critical bug would not self-correct. It requires an intelligent agent to identify and repair the issue. The same principle applies in biology, where random mutations more frequently lead to loss of function or harmful changes rather than improving the system. Intelligent oversight is necessary for correcting or optimizing complex systems, whether in software or biology. Conclusion. The concept of complex specified instructions in computer science mirrors the arguments for intelligent design in biology. In both realms, functional complexity and goal-directed arrangements of parts cannot arise from random processes. Software systems, like biological systems, require an intelligent agent to design, structure, and direct the functionality of individual components, ensuring that they work together toward a specified goal. The creation and maintenance of functional, purpose-driven code is clear evidence that complex specified instructions arise from intelligence, not from chance or natural law alone. In this light, the complexities found in biological systems, such as DNA, proteins, and cellular machinery, can be better understood as the product of a purposeful designer, much like the sophisticated software systems that shape our digital world today. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts. If you would like me to respond to your comment, please make a level 1 comment directly below the video. I will respond to all polite level 1 comments even if it takes me a while, due to other commitments.